my name's Haley Nevins and we're here at Del Campo High School and we have found a new z-test, and here's Katie with the definition.
Thanks, Haley. A z-test is a statistical test used to determine whether two population means are different when the variances are known and the sample size is large.
Step 1. State the hypotheses. The table below shows 3 sets of hypotheses. Each makes a statement about the difference D between two population proportions, P1 and P2. The first set of hypotheses, set 1, is an example of a two-tailed test, since an extreme value on either side of the sampling distribution would cause a researcher to reject the null hypothesis. The other 2 sets of hypotheses, sets 2 and 3, are one-tailed tests, since an extreme value on only one side of the sampling distribution would cause a researcher to reject the null hypothesis. Every hypothesis test requires that you state a null and alternative hypothesis. When there is no difference between the two population proportions, you state them like: a null hypothesis is P1 equals P2, and an alternative hypothesis is P1 cannot equal P2. Step 2. Formulate an analysis plan. This plan describes how to use sample data to accept or reject the null hypothesis. It should specify significance level. Any value between 0 and 1 can be used for this. Test method. Use the two-proportion z-test to determine the difference between the proportions. Step 3. Analyze sample data. Using sample data, complete the following to find the test statistic and associated p-value. The pooled sample proportion. We use this to compute the standard error of the sampling distribution. P equals P1 times N1 plus P2 times N2 divided by N1 plus N2. The standard error. Calculate the standard error of the distribution difference between two proportions. Standard error equals square root of P times 1 minus P times 1 divided by N1 plus 1 divided by N2. Also, you can use test statistic. The test statistic is a z-score, z, defined by the following equation: z equals P1 minus P2 divided by the standard error. The p-value. This is the probability of observing a sample statistic as extreme as the test statistic. Note, the analysis described above is a two-proportion z-test. Step 4. Interpret results. If the sample findings are unlikely, given the null hypothesis, it can be rejected. This typically involves comparing the p-value to the significance level and rejecting the null hypothesis when the p-value is less than the significance level. Here's an example of a one-tailed test. Suppose the Acme Drug Company develops a new drug designed to prevent colds. The company states that the drug is more effective for women than for men. To test the claims, they choose a simple random sample of 100 women and 200 men from a population of 100,000 people. At the end of the study, 38% of the women and 51% of the men caught a cold. Can we conclude that the drug is more effective for women or for men? Use a 0.01 level of significance. Here are the steps you would take to solve the problem.
State the null hypothesis and an alternative hypothesis. The null hypothesis is P1 is greater than or equal to P2, and the alternative hypothesis is P1 is less than P2. Note that these hypotheses constitute a one-tailed test. The null hypothesis will be rejected if the proportion of women catching cold, which is P1, is sufficiently smaller than the proportion of men catching cold.
Formulate an analysis plan. For this analysis, the significance level is 0.01. The test method is a two-proportion z-test.
Analyze sample data. Using sample data, we calculate the sample proportion P and the standard error SE. Using these measures, we compute the z-score test statistic. P equals P1 times N1 plus P2 times N2, divided by N1 plus N2, which equals 0.38 times 100 plus 0.51 times 200 divided by 100 plus 200, which equals 140 divided by 300, so P equals 0.467. To find the standard error, it equals the square root of P times 1 minus P times 1 divided by N1 plus 1 divided by N2. The standard error equals the square root of 0.467 times 0.533 parentheses times 1 divided by 100 plus 1 divided by 200, which equals the square root of the square root times 0.00373, which equals 0.061. So Z equals P1 minus P2 divided by this standard error, which equals 0.213. P1 is the sample proportion in sample 1, where P2 is the sample proportion in sample 2. N1 is the size of sample 2, and N2 is the size of sample. N1 is the size of sample 1, and N2 is the size of sample 2. Since we have a one-tailed test, the p-value is the probability that the z-score is less than negative 2.13. So we use a calculator to find that p times z is less than negative 2.13 equals 0.017. Therefore, the p-value equals 0.017.
Interpret results. Since the p-value 0.034 is less than the significance level 0.05, we cannot accept the null hypothesis. Note, if you use this approach, you may want to notice that this method is appropriate because the sampling method was SRS and the samples were independent.
Haley,
And I'm Katie.
and that is it for the Z-test report.